Welcome to Small Code Learns.
In this video, we will see one of the main pillars of OOPS polymorphism in C#. Let's make it super simple and clear. Here's what we're going to cover step by step. What is polymorphism? Types of polymorphism in C#. What is method hiding? When to use polymorphism? Now let's start with what is polymorphism. Polymorphism comes from two Greek words. Poly equals many. Morph equals forms. So, polymorphism means many forms. In object-oriented programming, OOP, polymorphism allows a single method, class, or interface to behave differently based on the object that is using it. Key purpose to design flexible, scalable, and maintainable code that can support different behaviors through a common interface. Types of polymorphism. There are two types of polymorphism. One compile-time polymorphism, also called static polymorphism, it's achieved through method overloading. Two runtime polymorphism, also called dynamic polymorphism, it's achieved through method overriding, interface polymorphism. Method overloading. Multiple methods in the same class with the same name but different parameter lists. At compile time, the compiler decides which method to call based on the number and type of arguments passed. Method overloading doesn't require inheritance and improves readability and code reusability. Let's go for example. Create a class calculator with 3 overloaded add methods. All 3 methods have the same name, add. But each one differs by O, the number of parameters, O, the type of parameters. This is called method overloading, and it's resolved by the compiler at compile time based on the arguments passed. This is an example of compile time polymorphism because the compiler decides which add method to call based on the number and type of arguments. Method overriding. Method overriding allows a derived class to provide a new implementation of a method that is already defined in its base class. A base class must have a method marked with the virtual keyword. A derived class must use the override keyword to change the method behavior. The method signature must be the same: name, return type, parameters. Method overriding enables dynamic, runtime, behavior. Requires inheritance, a derived class from a base class. The decision of which method to execute is made at runtime based on the actual object type, not the reference type. Let's consider this example without overriding concept. In this case, the base class method does not use the virtual keyword, and the derived class method does not use the override keyword. When we create an instance and call the speak method using a base class reference, it will always call the base class's version of the method. The derived class method will be ignored in this case because method overriding is not applied. Now applied override concept, with virtual and override. When the base class method is marked as virtual, and the derived class method uses the override keyword, the derived class method overrides the base class method. When we call the method using a base class reference, the method of the actual object type, example dog, will be executed. This enables runtime polymorphism. Without virtual and override, the base class method is always called. With virtual and override, the method of the actual object is called at runtime. This is method overriding in action. Now we move to interface polymorphism. Multiple classes implement the same interface, but each provides its own behavior for the methods. Let's see it in example. Let's create something called an interface, named iVehicle. Think of an interface like a contract or a rulebook. It doesn't contain any code or logic, it only defines what a class must do, not how it should do it. In this case, the rule is: if you are a vehicle, you must know how to drive. So, inside the interface, we simply write the method signature, void drive. Now, let me show you two different classes, car and bike. Both classes implement the iVehicle interface and define the drive method with different behaviors. In the car class, it prints car drives. In the bike class, it prints bike drives. Next, we declare a reference variable of type iVehicle called vehicle. This reference can point to any object that implements the iVehicle interface, such as car, bike, truck, and so on. Even though vehicle is of type iVehicle, it is now holding a car object. When we call drive on the vehicle, it executes the version from the car class because the actual object is a car. In the same way, we can call drive method in bike class. Vehicle is like a remote control. It can control any type of vehicle. Right now, it's connected to a car, so pressing the drive button makes the car drive. Then, it's connected to a bike, and pressing the same button makes the bike drive. This is what we call interface polymorphism, the ability to use different objects through a common interface, where each object defines its own behavior. Method hiding. The method in the derived class has the same name as a method in the base class, but it is not overriding it. Instead, it hides it using the new keyword. Think of it like this. The child, derived class, is introducing a new method with the same name, but the parent, base class, still has their own method. You choose which version you want to use. Let's see the example. Let's learn method hiding in C# with a simple example. In this example, we have a base class called message, which has a method show, and derived class called custom message. In this class, we define a method with the same name with new keyword of method hiding. Let's see how it behaves with three different objects. First instance created for message class and called its own method. This is a regular base class object. When we call message1.show, it prints base message, hello. Next, instance message2 created for derived class. When we call message2.show, it prints custom message, welcome. Create reference for message class and object for custom message. When we call message3.show, the output is base message, hello. When you use new, the base class method is hidden, not overridden. The method that gets called depends on the reference type, not the actual object. So if you want runtime polymorphism, where the actual object decides the method, use virtual and override. Why use polymorphism? 1. Code reusability. You can reuse the same method name or interface across multiple classes. This reduces duplication and makes your code cleaner. Example, a print method can be reused for printing text, images, or documents, each with different behavior. 2. Improved flexibility. You can write code that works with objects of different types without changing the logic. Example, a method that accepts a shape parameter can work with circle, square, or triangle objects without rewriting the logic. 3. Easy maintenance. Changes in one class won't affect others that use the same interface or base class. Example, if you fix or improve the draw method in the circle class, there's no need to modify the code that uses the base shape type. 4. Abstraction support. You can hide complex implementation details and expose only meaningful functionality. Example, the user just calls .drive on iVehicle. They don't need to know how a car or bike actually drives, it's abstracted. 5. Loose coupling. Your code depends on interfaces or base classes, not concrete implementations. Example, you can switch from a SQL database to a Mongo database without rewriting the code that uses iDatabase. So, polymorphism lets you write code once and use it in many different ways, making your applications more powerful, easier to manage, and open for future changes. Now we will see when to use polymorphism. If you want to provide many methods forms, then use method overloading, compile time polymorphism. What it means. When you need different ways to perform a similar task, based on the input. If you want custom behavior in subclasses, then use method overriding, runtime polymorphism. What it means. You have a base class method, but want different behavior in each subclass. If you want common behavior through interfaces, then use Interface polymorphism. What it means. If you define a contract using an interface, and many classes implement it different to behave uniquely. Now you've understood the concept of polymorphism in C#, along with its three main forms: method overloading, method overriding, interface polymorphism. These techniques make your code more organized, extensible, and easier to maintain. Polymorphism is a powerful tool that lets you build scalable applications with clean architecture. See you in next video. Thanks for watching. Please like the video and subscribe. Small Code Learns.